Welcome back guys sa ato ang class on electromagnetism. This is still on the topic on the chapter electrostatics, and we are particularly on the subtopic. We left last time sa Gauss's law, so we continue with this. So we have two problems here as an example of an application of Gauss's law. So I believe ang problem 1 is kinda or somewhat related or maybe exactly the same sa problem set na akong gihatag last 2 weeks ago. So we'll solve it together, these two problems. So for the first problem, find the electric field inside a sphere which carries a charge density proportional to the distance from the origin. This is given by the rho equals kr. So this is proportional to the distance of the origin. Okay. Okay, so we have here it's not working. So we have our rho here. So this is a volume charge density per the charge density per unit length sa imong volume for some constant k. Our Gaussian surface would be a concentric sphere. So we can calculate the electric flux of the system if we recall the Gauss's law. So the flux of the system, that is the number of electric field lines passing through a surface perpendicular to the direction of the electric field. So we have the closed integral over a surface. This is the electric field dA. Okay, so the integral over dA is this. This is the surface here is just your concentric sphere. So the area of the sphere is just, if integrate nimo siya, we have 0 to 2 pi. That is for the sa imuhang dphi, okay, and then sa imuhang 0 to pi, you have your cosine theta. So since constant ang imuhang r, we just have to make that constant. Then we have your, this is dA, and then this is E, okay? And if you integrate that one, this is r squared. So r squared cosine theta, where the limit of theta is from 0 to pi, and then the limit of phi is just, or phi is 0 to 2 pi. So we have 2 pi r squared E. That would be E of r. I'm sorry. Ang pag-integrate ani is, this would be 2 pi, and this would be 2 pi, and this would be 2. So integrate mo ang cosine theta, d theta. So this would be 4 pi. So this is 4 pi r squared E of r. And so the charge enclosed by the Gaussian surface can be obtained by integrating the charge distribution between, so integrating between, then we have integrating between, let's say we have r prime equals to 0 and r prime to r. So that would be from the origin to some arbitrary location or distance r. Okay, so we can calculate for the Q enclosed. Okay. For the Q enclosed is just siya, diba? We have rho dr. Okay, We have prime here, prime. Okay, we are integrating over a volume. And this is from 0 to R. Ito atong i-mention kanina. And then ato ang raw, diba, is just KR. Okay, so we have, our notation here should be prime. Kay R man ang ato ang limit sa integration. So KR prime. And then, this is raw d tau, sorry. This is raw d tau prime. Okay. Now for the d tau prime, ano man na siya, diba? We have r squared cosine theta dr d theta dv. But since ang imuhang volume charge density is dependent naman siya sa r prime, so constant na itong theta and phi, so automatic na to siya. Ang result niya is 4 pi, right? So ang mabiling na lang is you have 4 pi r prime square. And we have dr prime. If you integrate this over r prime and dr prime, you will get pi k r to the 4. Okay? That would be your Q enclosed. And then we will apply this one sa atong Gauss's law. Alright? Atong Gauss's law is ato naman tong, we have this one. E dot dA equals Q enclosed over epsilon naught. Right? So that our Q enclosed, we already have our Q enclosed, so that our flux would be given by this. So 4 pi r squared E of R. Dili mo na siya gikan, right? So this is Gauss's law equals, so this is this one, and then we have Q enclosed over epsilon naught, and Q enclosed is just pi k r to the 4th. So, ang gipangita is ang electric field man. So our electric field would be just this one, pi k r to the 4th over epsilon naught. Over epsilon naught over kani siya imuhang 4 pi r squared. So mag-cancel naman na ang imuhang 4 pi. Mag-cancel ang pi, and then what we are left with is 1 over 4 epsilon naught k r squared. So this would be now our formula for the electric field. Okay, that's the electric field for problem 1. If we go back sa to ang this one. Now for the problem 2, similar na siya sa problem 1, but this time instead of a sphere, we'll be using a cylinder ang imuhang problem. Okay. So coaxial man siya. So a long coaxial cable carries a uniform positive volume charge density rho on the inner cylinder of radius A and a uniform surface charge density on the outer cylindrical shell of radius B. And the surface charge is negative and of just the right magnitude so that the cable as a whole is neutral. So you find the electric field in each of the 3 regions. First is inside the cylinder, that would be R less than A. Second is between the cylinder, R is between A and B. And then we have outside the cable, so R should be greater than B, or B is less than R. So let's do this. So ang problem na to is to i-drawing sa, I'm not good with drawing, so pasensyahin lang ni siya. So, Okay, this is solid man siya, volume. Okay, so inana siya. So ang radius niya ani is A. Then na ako'y coaxial niya na ana siya. So I don't know if ma-imagine ka ninyo. But in this case, mo na siya. And this is B, right? So, naano siya volume charge density. Yung cable, ang inner niya is naa siya raw. And then sa sulod di siya, ang outer is naa siya surface charge, let's say surface nga, let's say sigma. So naa siya sigma. Then in such a way nga ang total niya, the total is neutral. Okay? So this is positive, this is negative. Okay? As we can clearly see here that the charge distribution has a cylindrical symmetry, and if we want to apply Gauss's law, we will use a cylindrical Gaussian surface. Okay, so we'll be using cylindrical Gaussian surface. Now we consider a cylinder of radius r, ang imong Gaussian surface could be depende kung asa siya. For example, if you want to find the electric field inside the katong solid na cylinder, this one of radius A, then we'll be using a cylindrical shell or our cylindrical Gaussian surface as our kanisya of radius r. Let's make use of this one. So pwede ta mo gamit diri og kuan. So let's say kani atong pinaka-shock now. So kana nasa sulod. So this would be our cylindrical Gaussian surface if you want to calculate the first region katong sulod sa kaning cylindrical nga solid. This is of radius r, small r. Okay. And then this is of length L. Length L na siya. Okay. So we want to calculate the electric field. So ang electric field di is directed radially outward. So kana siya. Diha ang direction sa imong electric field. Ang electric field diri theta is 0 since imong electric field is perpendicular siya sa imong dA. Right? This is electric field and this is dA. So the electric field diri theta sa side niya is just 0. Okay? Now we want to calculate the electric field for each region. Okay? But before that, it's important or masayo na nga to ang trabaho if we calculate first the Q enclosed for each region. Okay? So, mugamit gyapon ta sa ato ang Gauss's law given by this equations of flux. This is surface. And we have the formula for our Gauss's law. Okay? So, dA man siya. So, ang area sa imuhang cylinder, atong shell lang niya is just 2 pi r for the Gaussian surface, right? Radius r and of length L, and then multiply by our electric field. So, you want to find this electric field here. So, makuha mo na itong electric field, diba, by using the Gauss's law. A dot dA, this is equal to Q enclosed over epsilon naught. So, to get the electric field, we need to calculate first the Q enclosed. So let's calculate the Q enclosed in 3 regions. Okay, first, for R less than A, what would be our Q enclosed? Okay? So for the Q enclosed sa R less than A, right? Since ang imuhang volume density for that case is uniform naman siya, so there's no need for an integral. So actually magawas ra siya sa integral. So we have rho beta, wala man na siya. Since constant naman na imong rho, so we have rho integral beta. This beta is the volume sa imuhang Gaussian surface, right? Imong cylinder. Now the volume of the cylinder, we know it from our previous knowledge sa high school, and I think sa inyong calculus po, that would be rho pi r squared L. So this one, pi r squared L is just this one. Kani siya nga sorry. Where's the pointer? Kasi mo ang Gaussian surface pa kaning labeled in blue kaning sa graph. Ito to ipakita niya tara. So this would be our Q enclosed sa R less than A. Now for region 2, that is R is between A and B. For the Q enclosed there, so we have rho theta. Again, rho is taken out of the integral. And this time, ang imong limit sa integral sa imong R nga part is just from 0 to A, right? Because ang na-enclose man sa imong surface is the total charge sa imong cylinder. So you have, let's say, duweng ko balik ka, mao ni siya ang imong katong solid ito. Right, katong solid nga part ni siya. And then muna siya ang katong sa gawas, right? What would be the electric field or the Q enclosed di ay? This is of radius A. Between, so this is B man is siya. So ang between niya is naa diri, right? So mag-drawing ka ana og Gaussian surface diha dapita, so it would be like this, right? Na diha ang Gaussian surface. So for the Gaussian surface, unsay na-enclose niya nga charge, right? Which is kani siya, ang whole thing yun. Alright? So ang whole thing niya, which by the way, we have this equation. So ang R niya, ang iyahang limit is said na small r, it's just a small a, ang imong total yun, ang imong na-enclose, di ba? Ang total charge, which is ang radius niya sa imong cylinder is just a small a. So we have this. If we integrate that one, so we have rho pi a squared L. Okay, so we have that equation. Now let's go to R is greater than B. What will be the Q enclosed? So wala na siya calculation kay mao naman ta nga ang total charge outside kay ang total niya we have neutral. So ang Q enclosed just 0. Okay? By this time, we can now apply the Gauss's law. Wala ko yung space. Erase na. So, tara ang Gauss's law kung gamiton. Alright? Where kanisiya is mao man eh. So therefore, E of R would be 1 over 2 pi RL Q enclosed over epsilon naught. Right? So, makakalculate na po ta kung sa electric field for each region. Tara. So for region R less than A, the electric field is substitution naman siya class. right? This one, using this formula, we have our Q enclosed, Tora. Q enclosed, Q enclosed, I have Q enclosed. So, imo na siya i-substitute. This would be an exercise sa inyo na lang. Ang details niya, basta kay ang result ani niya would be 1 over 2 epsilon naught R rho. Okay? This is for the first region. For the second region, that is in between A and B, the electric field would be 1 over 2 epsilon naught A squared over R rho. And then the electric field sa gawas would be, of course, ang Q enclosed is 0, so there would be 0 net electric field. Okay, so that would be our final answer. So dali na siya, class. Actually, dali na gid kaayo naalang kay ma-establish nga symmetry. And then, if ma-apply na to ang Gauss's law because of that symmetry, then the calculation would be very, very much easy and straightforward. Okay, let's move on. Okay. So we move on to the topic electric potential. In a previous discussion nato, ato ang na-discuss ang one of the mathematical properties sa imong vector, let's say electric field is a vector. Di ba nakaana man ta nga we know nga ang del cross E is 0. Okay? Ang ihang curl niya is 0 because electric field has no curl. It is spread, divergent man siya. So, there's no way nga makakuha kag curl sa imong electric field. Now, if this is the case, naatay identity sa math nga if we have this, let's say del cross say E na lang yun. So L cross E is 0, then it must be nga ang imuha, so equal na siya sa this is equal to 0. So if that is 0, then it must be nga ang kana siya, it must be equal to the gradient of something scalar. Let's say V na lang, kay V matang gigamit diha. It could be any actually a variable. So nana siya nga identity sa math. In short, if we have del cross the gradient of something, it could be anything, say V na lang na diha, that is 0. Okay? So therefore, that's why naataan nga equation, it must be nga ang electric field, it must be a gradient siya of something scalar function. Okay? So negative ni siya ang sign niya, it's because later on na-realize man nila nga this is actually a potential or volt. If you have a source, this is direction sa electric field. Kung asa ang direction sa electric field daw of maximum increase, this potential decreases, right? Ay mo potential if naka sa infinity, naka sa layo ka, mo gamay siya as to the direction sa imuhang electric field. That's why negative na siya diha. So we'll be using this very important nga identity or nga kaning equation, because upon knowing nga ang imong electric field, ang ihang curl niya is 0, it must be this is the case, right? So na ako'y some kind of a potential, then if I take the gradient of that would be the electric field. Okay? So naa siya relationship ba? Knowing the potential, if we just take the gradient, then we can solve for the electric field. So sa kaning identity na mapa-easy nimo ang life sa physicist ba? Or any individual na magkailangan ka mag-solve sa electric field, because V is just a scalar function. Scalar man na siya. No direction. Okay? Wala siya direction na imuhang no property. It's just ang iyang magnitude. And working with scalar is a lot easier compared to working with vector. We'll see later as we do more examples. Okay. So let's take the line integral of gradient of v between point A and point B. So we obtain this. We have this identity here. The integral from A to B, line integral del v dot dl. This is just this one, VB and VA. That is equal to this one, the negative of the, because negative right? Negative of this integral E dot dl. So taking A to be the reference point and defining the potential to be 0 there. So let's say ang reference point na to is actually, na zero gina siya because the reference point would be at infinity. So if you have the source, so this is B, and ang reference point na to is A, very far. So the potential there is 0. Right? So we are left with the potential at V of V. So, muna siya. So we have this. So the integral, so ang VA na to is, VA is 0. So we get this. So the choice of the reference point A of the potential is arbitrary. So choosing the reference point to the potential amounts to adding a constant to the potential. Let's say, instead na directly from A to B, mahapit pa siya, let's say, na A prime diha. That's why sa mga integral na ako'y let's say, start siya from, start na sa A, tapos i-extend na to siya to A prime, okay? So, yung mga integral mo, start ka from A prime to A, that's why na ako'y A prime to A, and then we have A to B, so I have A to B, okay? So, ang kana siya nga integral, it's just tantamount to adding a constant to the potential. So, instead na directly na ako'y VB, na siya additional factor nga K because of this A prime. So, where K is just a constant, and it's independent of B, and is equal to this. So, ano yung atong K? So, however, since the gradient of a constant is equal to 0, so we just left with this. So, ang E prime, if whether mo add ka o katong A prime ni mo nga reference point, it will be just E, the same E, electric field. So thus, the electric field generated by B prime is equal to the electric field generated by V. So the physical behavior of the system will depend only on the difference in the electric potential. Okay, so it's like it's a non-conservative entity, so just like gravity bitaw nga. Dependent na gid siya sa initial and final point, not dependent on the intermediary, ang imuhang path nga giagian, but it's just like that. So the most common choice of reference point in the electrostatic problem is of course infinity, because the potential there is 0. And the corresponding value of the potential is usually taken to be 0. Okay, that's what I've said. So the reference point would be now infinity. Okay. So from infinity to B, you calculate now the line integral of the electric field. Say na ako yung electric field source dira. This is the electric field direction niya. So, na ako diri start ko from infinity. Tapos, I calculate the line integral padulong din ha. Let's say at point B. Right? So, I'm moving against the direction of the electric field because ay mga potential mo increase man. Okay? So, this is V diha is 0. V is 0 at infinity. Then I slowly bring this entity here, let's say, kung gusto i-calculate ang potential, up to point B, and I calculate the line integral given by this. And so the unit of the electric potential is actually volt. Okay? Volt na siya. So volt is, kanya siya, that's actually joules per coulomb. So joule is a unit of energy. That's why gipangalan siya og potential, because ang ihang unit is energy man siya in terms of energy per coulomb. Okay? So that's why it's potential. So let's solve for this one. So one of these is an impossible electric field. So kinsa ka diya ang imposible nga dili pwede siya mahimong electric field, di siya pwede an equation or a form of electric field. So how do we test it? Well, we test it if we calculate the curl of that electric field, and if it's zero, then it is a valid electric field form. If it's not zero, then it must be dili siya electric field na form. So let's do this. Let's calculate. So first, sa atong problem A, atong electric field, electric field is given by this. K xy I hat plus 2yz j hat plus 3xz k hat. Wala siya. Then ang B na to is okay, let's take the curl of the first electric field. Del cross E. Kini medyo we have to take it yun nga isolve na to siya ang kuan ba ang curl nga. Although medyo siya medyo laborious, full of labor. So we have partial x, partial y, partial z. And ang x component niya is xy, 2yz, 3xz. Sakto ba ni? Yeah. So gani ko ana ni. So you have I hat, do the basket method. So you have partial y, 3xz minus partial z, 2yz, right? So minus j. Okay. So this would be partial, I hope makita pa din ninyo, partial x, 3xz minus partial y, xy, partial x, 2yz minus partial y, xy. Okay. So as you can see here, if mo siya i-calculate, kani siya partial y, wala naman ni siya. But this one na siya value, right? Kani na value. So in short, dili siya not zero, right? It will give you non-zero value. And that only means nga ang imuhang curl is not zero, thus not a valid electric field. Okay. Not a possible electrostatic field or electric field. Okay. Now for letter B, if you mo siyang if you take the curl of that, so kamo na bahala na lang din, you do your thing, you will find out nga if you calculate the electric field using the same formula that we had, same process, same method, it will give you zero. Okay? So therefore, the second form of the electric potential is possible or it's valid. So this one is valid. Okay? Valid na siya. How about for problem 2? You suppose the electric potential is given by the expression for all r, a, and lambda are constants. You find the electric field E of r, the charge density, and the total charge Q. So how do we do that? Now finding the electric field given the potential is straightforward because your potential is just a scalar quantity. So let's try to do this. Nga naman tayo formula nga pwede na ito magamit. Sorry. Okay. Our formula is just, given the potential, we can get the electric field. Right? It's negative. So, kana lang. Okay, so we have negative del. Our equation sa itong potential is just A e to the negative lambda r over r. Right? So that is equal to, so derivative pa siya with respect to r, kay r man po'y variable nga naa, the rest kay wala. So it will not matter sa imong, kay 3 dimension mo na imong gradient. Right? We have r theta p. This would be a to the negative lambda r over r. Then r hat ang imong direction because scalar quantity, but the whole thing is a vector because we are looking for electric field. So the result ani is imuha naman ng a derivative product rule or division rule. So basta kay ang result niya would be this lambda a e to the negative lambda r over r. So this time got derivative ko with respect sa exponent, keeping the r constant, and then derivative na po ko sa denominator nga r, keeping e to the negative lambda r constant. A e to the negative lambda r over r squared. R hat. So that would be the electric field na. So this would be the electric field nga equation. Next is how do we look for the charge density? So for the volume charge density, magamit tayo itong differential form sa Gauss's law. That would be del dot E equals rho over epsilon naught. Right? Mamana siya ang formula. So therefore, we have rho equals epsilon naught times del dot E. So since ang E na naman tayo E, di ba, nga electric field nga form given by this one sa previous na ito nga calculation. So i-substitute na nimo, we get this. Dot. So constant naman ni. We have constant ang A, right? Constant ang A. So magawas ang A. So we have, so igawas po dato ang mga uban constant, like ang common terms, I mean. So we have this form. Common nato ang e to the negative lambda over r squared. And if you take out this e to the negative lambda over r squared, then you get this one, 1, right? 1 plus lambda r. So, as you can see in this equation. So, we can now take the dot product sa kanila case. So taking the dot product for this one is like taking the derivative na po, because anyway, R naman siya in terms of R, the rest kay constant ang theta and phi. So we have product rule here. Okay, so product rule is here. So this, if you can consider this one as one entity, and then this is a separate entity. Okay, we can take the derivative of this one first, and then keeping this the other constant, and then lahi na po yung derivative sa sunod. Okay, so let's continue. So we have ato i-constant ang kanisya first term, 1 plus lambda r e to the negative lambda r. Then we have this, right, plus so kanina po ang ma-constant ang sa pika, so we have r over r squared, and then we take this one. Or we just simply do this. Dot na siya diha. Then, just simply take the derivative sa kana sa sulod. Okay? So, after doing that, we get this one. However, from our previous knowledge, kani bitaw siya nga equation, di ba nag-solve ba ani last time kani? This is actually a Dirac. This is actually a Dirac function if imo na siya perform. So we get, i-refer lang sa previous chapter, 4 pi this one. So it's a Dirac function minus okay. So we have this equation now. But since it's a Dirac function, naara siya value if ang imong r is equal to 0. The rest, wala siya value is 0 siya. So naa siya value ang imong function as a whole, this one, as a whole, na siya value if r is equal to 0. Now, if r equals 0, this becomes 1, ang imong exponent, then this one will become 0. So, we are left with just 1. So, mahimo na siyang 4 pi Dirac delta minus this equation over r. Okay. So, that would be our rho. Okay. Next is, you get the total charge Q. So how do we do that? We already have the chain of effect man siya na naman tayo, no? So we can get the Q enclosed, or the Q total, should I say. So the Q total would be rho d tau. Right? So rho d tau, substitute naman na nimo. So we have from 0 up to infinity, we have epsilon naught a, and then we have 4 pi cube r minus lambda square e to the negative lambda r over r, right? And then theta would be 4 pi r squared, tama? dr. So if you integrate that one, you get this 4 pi epsilon naught a and have 0 to infinity. So, ano na siya? We have 4 pi the Dirac delta function dr minus this one we separate siya, right? So, pag multiply ana maka-cancel man ang r, so we have r na lang din ha. Lambda square e to the negative lambda r dr. Okay, so we have this. So, tali raman nimo ang pag-integrate sa kanisya because sa Dirac delta function. So, nara siya value if r equals 0. Okay, if r equals 0, then this whole thing would be 0. So, we are just left with 4 pi epsilon naught a, and then the integral of this one. I hope that was clear. So, dinan ako mag next page. Ako na i-erase lang sa okay. So, how do we integrate this? How do we do the integral? So, consider this integral r e to the negative lambda r. Okay. So, yung mga technique na ito nga pwede gamitin. So, now one very good, very nice trick is actually to do this. D over d lambda 0 to infinity, and then e to the negative lambda r dr. Equal na sila. Right? Because if you take the derivative of kaniki, lambda naman siya, this is lambda. Lambda. So if we derive the lambda, if you derive this integral with respect to lambda, mo gawas na gihapon siya nga equation, right? So it's actually the same. So that's a very nice trick, because if we have this, mas dali naman na siya i-integrate. EU du naman na siya, right? So ang integral anak niya would be d over d lambda. Integral niya would be negative 1 over lambda. Tama? Then e to the negative lambda r from 0 to infinity. Okay? And if you do that, d over d lambda, that would be negative 1 over lambda. Then take the limit, right? That would be e to the negative infinity minus e to the 0. So that would be d over d lambda zero naman na siya, di ba? Kay 1. So, negative 1 over lambda times negative 1, that would be 1 over lambda. Or mag-x na ko lambda eh. Sorry for that. So, mag-derive na din ta. D over lambda, i-derive din mo ang 1 over lambda with respect to lambda, that would be one over lambda square, right? So, na siya negative na diri. Sorry about that. Na siya negative. So, that would be positive na din diri. Okay? So, ang result niya is just 1 over lambda square. So, going back sa kanyang integral, sorry about that. Medyo gubot na. Kamay na kayang space. So, we have 4 pi epsilon naught a, and then ang integral ano niya is just, di ba, constant ang lambda square, and then we have 1 over lambda square. So the result would be 4 pi epsilon naught a. right? 4 pi epsilon naught A. So that would be the Q total. So by the way, there must be a negative sign here. So negative na siya. This is negative because in the first place, 0 man di ba diri? 0 man siya. And then we are left with this second term. So this is negative. Okay. So our Q total is this. Just okay. So dali ra kay siya nato nakuha because given the potential, we can solve for the rest. Okay, scalar naman ang potential. This one, scalar ang potential. Given the potential, we can get the electric field. Given the electric field, you can get the rho. Given the rho or charge density, we get the Q given by this. Chain reaction na siya. Let's proceed. Also, the charge distribution rho can be easily obtained from the electric potential. Of course, can you see? You have this. Ito ganina is taas kita giagian, di ba? Para makuha ang rho, we get kanya itong gigamit, right? Pero pwede man nga, ang makuha na ito ang rho, directly sa potential by having this identity here. Right? So we have negative epsilon naught del squared V. Okay? Just taking the derivative twice sa imuhang potential, you get also rho. You can actually check that one. You can do that at home, at your own spare time or free time. Then your result must coincide with this. Kung coincide siya dapat sa to. Oh, na-erase na ako. But you can go back sa previous nga video, previous few minutes or seconds maybe. Just solve na to ang rho. Okay. And this equation can be written as this one. Mao na siya. So given the potential, we can get the rho. This is actually known as the Poisson's equation. Poisson na siya. Okay? If ang imuhang rho, kasi wala kay charge density sa surface or 0 ang net, if this is equal to 0 instead, then that would be termed as the Laplace equation. So this is the Poisson. This is Laplace equation. So the electric potential generated by a discrete charge distribution, we can also solve for the potential given by this equation. Okay. So what if ang imuhang potential is, imong electric field is dili given? So how do we solve for the potential? Because sa namatay formula, di ba nga, ang electric field is given by this. How about we want to calculate the we can get the electric field given by potential. Also, we can get the potential given the electric field by, can you see? Katong sa previous na ito nga equation. Right? We can anyway, we have this formula. We can actually get the potential here using equation 23. So this is somewhat similar to the one that we had sa pag-calculate sa electric field using superposition principle. So this is the potential generated at each point given by a discrete charge of charge Q. Q1, Q2, Q3, you get the potential sa V1, V2, V3, and so on. Then you can get the total potential by summing all those individual terms. So where V sub I is the electric potential generated by the point charge Qi. So a point charge Qi located at the origin will generate an electric field potential V sub I equal to this. This is the potential. Okay. Because this is ano naman siya? This formula is actually katong line integral na E dot dl. Okay. So this is the electric field sa point charge. You have Qi caused by this electric field caused by a point charge, Q1, Q2, and so on. Tapos, continuous man siya, you have this. So, Qi over R squared. So, actually, discrete paghihapon ni siya. You have Qi over R squared dr prime. And then, if you integrate that one, you get this. 1 over 4 pi epsilon naught Qi over R. So, this is the individual, so Vi, right? And if you take the sum, so diha na siya sum nimo ang discrete charges. But if continuous, then we transform this to integral. Then this becomes integral. Okay. So in general, a point charge Qi will be located at position Ri, and the electric potential generated by this point charge at position Ri is equal to, given by this. So, kani siya is katong sa source charge. And this one is katong sa field or location. Right? O asa nimo gusto i-calculate ang imong electric field. O sa lahi nga mga books, usually sa ato ako din case, we'll be using R, kana siya. Where R is given by this one. So the total electric field generated by the whole set of point charges is equal to total naman siya. This one, the total. This one is individual, ang isa ka point, right? Let's say kung V1 na siya, this becomes 1. If 2 na siya, this becomes 2. So adding all those potential from 1 up to n will give you this equation 26. As I've said ganina, naatay premonition, di ba? Once we have a summation, that's only true for discrete. And in reality, di man discrete ang imong charge distribution. It's actually continuous. So we can convert that from summation to integral. For the line charge, the surface charge, and the volume charge. So this is not new to you. So these are not new to you anymore because this is similar to the electric field nga itong gigamit last time. From summation to integral. This time is potential. Now, malipay tayo if potential atong gamiton because we are working with scalar. Okay? Because potential is a scalar function. Working with scalar is a lot easier compared to working with a vector function. That's why mas nindot i-calculate daan ng scalar function, potential, to get all those other entities na itong gusto pang itaon. If you want to get the electric field, you can do that. If you want to get the surface charge density and total charge Q, we can also do that just by knowing or calculating first the scalar function potential V. Okay. So let's have this example. So this is similar sa katong previous example nato, diba? Especially kaning A. Nag-calculate ta last time. We can go back sa previous video. Nag-calculate sa electric field, di ba, at this point. Tapos nagamit ta, mas lisod to siya, kaya nagamit ta og cosine theta, ang mga Pythagorean theorem na to, diha, direction also of the electric field. We found out nga ang electric field ani at point P, di ba, mag-cancel man ang X ani, what only matters is ang potential, ang electric field niya at Z, hat direction. If you have this one, QQ. This time around, we will solve this not directly on yung electric field, but we'll calculate first the potential V. And then we'll get the electric field later by having this formula. Right? So, at na lang i-continue sa next video para di kayo siya taas. Okay? See you in the next video.